We want to take a few minutes today to just talk through this concept of networking and how we design our networks to operate correctly with NDI in a broad range of theaters. Okay, so I have spoken to probably hundreds of installers or clients or people along the way who are installing NDI in various places, and it is very much so, like what was said earlier in the show, a habit of how it is that we design our networks to operate. And as time progresses, things get better, right? But one of the older styles of doing things is to just set everything up with its own static IP address, and then you know where everything is, and you should be able to find it quickly on the network. It also, in theory, requires a lot less sophistication on the design front, meaning that you can deploy them quickly. Should be pretty straightforward, and then they should, just never change. Nothing will ever change because you've set the settings as is. Well, there are some things to consider when we talk about static networks, mostly because static networks are the traditional way for a very long time that AV over IP has been done. Standards like, Dante, for example, is one of the key elements where they can be set with static IP addresses, and then those things never change. And the data that's passed between those endpoints is pretty minimal, and so it doesn't require a whole lot of sophistication or traffic routing or anything like that to really make it happen. But when we talk about high performance video, which is really what NDI is, it is that beautiful merriment of high performance, low latency video for an IP standard. It is the best that's out there, hands down. I don't know of another one that's better than NDI. That's as sophisticated and as it delivers the quality that it does. And that's not me just being biased. Just NDI in general is by far the easiest in the AV over IP video realm, particularly. It delivers the best quality for the lowest amount of overhead, meaning that it doesn't take a whole lot to get you up and running. But static networks have always been kind of a problem, mostly because when you design a static network for NDI, like you would design one for Dante or like you would design one for other AV standards, we really lose out on some of the sophistication that comes along with, other styles of networks, in particular DHCP. So how do we set this up? How do we think about static networks so that they will work consistently, so I can have the things that I want, but I can deliver the NDI standard? And there's a couple of pieces that are really key here. The very first thing out of the gates is you really need to be operating in a layer 2 or layer 3 switching environment. What this is going to provide you with is the switches and the network infrastructure that you're running will have the processing power to transfer the amount of data that we're talking about, right? So in a NDI HX, let's just say HX2 world, you're moving at the speed anywhere from maybe 3 to 10 megs. If you're in HX3, you're running anywhere from, 5 or 6 all the way to whatever you want to turn it into. And in full NDI, for full HD, which is a 1080p 60 signal, you're easily talking 140 megs a second. Okay, so we're talking about a ton of data that's actually happening at lightning speed. And if we take away the actual managed portion of the network, if we take away the layering portion of the network, and we just have a basic unmanaged network, there is really no way that data is going to successfully, over long periods of time, get from point A to point B without having some sort of hiccup. And so it's really important that at least we have the processing power required to pass large, enormous amounts of data at lightning speed. And the way you do that is you buy a switch that has some level of sophistication. Look for layer 2 or layer 3 switches. Now, a layer 2 switch is just mostly a managed switch that operates on the network layer 2, okay? We can get into, I'll do this at a later time, talking about the actual layers of a network. But being able to pass IP information, being able to understand routes through the network. That's what we're talking about with layer 2. Most layer 2 switches are going to have, for example, an onboard routing table. What that is a packet will come in and it's going to a destination. And over time, that routing table is going to accumulate data and remember data as to where certain endpoints are. And so if we have a network, even just a single switch network, and the packet comes in and says, hey, I need to go to 192.168.1.12. A layer 2 switch will know which port to send that packet. Okay, it will have the routing data logged and saved internally so that it knows if I need to get to that IP address, or if a packet needs to get to that IP address, I need to go out this port because that's where they're located. All right. A layer 3 is something that can govern networks. Okay, so this usually has something like a DHCP service on it or has the ability to do that. It can set up its own VLANs. Okay, so it can isolate and configure VLANs. It can govern VLANs. All right, so if you have devices that are joining networks that are set in DHCP, that layer 3 can issue an IP address for that VLAN, even if that switch doesn't have that VLAN on it. You know, it has multiple layers. It provides a number of services. It will do something called router delegation, which means that in a sophisticated network, and you have multiple, let's say, layer 2 switches, it will figure out who is the top dog on the chain and delegate that routing table to be the master. And then the master list gets aggregated out to the other switches in line, the other layer 2s. And so everybody has up-to-date information. It means that that switch is responsible for, when something changes on the network, logging that information on the master routing table and then delegating that out. Okay, it's another layer, it's another level of sophistication. But to do NDI in general, you need to at least have a layer 2. Something that has onboard memory, something that has a relatively decent processor, something that has the ability to process packets. In SOHO unmanaged switches, a lot of that, it's not a universal statement, but a lot of that is not available. It isn't even on board. The silicon's not able to actually do that. It doesn't have any sort of high capacity processing ability. It's usually just a quick, easy, out of the box, could even be an ARM process that's just basic routing. Time is not of the essence. And it's really hard to qualify which unmanaged switches and which ones do and which ones don't. Because there are some out there that operate okay. It's not a hard and fast rule. There are some out there that, okay, perhaps we can get away with that. But the issue then becomes expandability when you start plugging in additional devices or additional computers even, or additional nodes on the network. Can that thing really keep up? Can it delegate? Can it isolate a problem? Can you prioritize? Things like that on a layer 2 switch traditionally means that it's a managed switch. Now, there is a difference, by the way, between smart managed and managed. So if you're going to Amazon right now and you're like, okay, let's just find out what I'm in for here. If you're going to Amazon or you're going to your favorite, network purchasing realm, type in layer 2 managed switch. And anything that comes up that says smart managed, ignore that. Because a smart managed switch is essentially, again, not a hard and fast rule, but it is essentially a unmanaged switch an unmanaged switch with a web interface. Let's put it that way. It is generally cost effective. Okay, it's going to be lower in price, but it's going to also be lower in performance. So you want to start on a layer 2 managed switch. And a great example of this is the entry-level switches for the M4250 realm, the Netgear M4250 realm. Those are layer 2 managed switch. Actually, they're layer 3s, but we won't overcomplicate things. So the 4212, okay, that entry-level switch that's in the 4250 series, that's a great layer 2 switch to kind of start your brain in thinking. Now, Netgear goes one step forward and customizes it for NDI, which is a huge advantage to you as the end user, but we won't. This isn't a Netgear commercial. This is about static networks. So the first thing you need to do is get a managed layer 2 switch at least. The next thing you need to do, though, is to understand the base functions that you're losing, okay, when you're configuring static. NDI devices, from what I can gather, NDI devices generally assume that the network has been informed. All right? That can be maybe the title of today's show. They assume that the network has been informed. But when people configure static networks for AV installations, they actually are doing it so they don't have to do all the extra customization. Okay? But it doesn't change the fact that NDI devices assume that the network is aware of what's going on. And so when you set a static IP address on a network node, which is what NDI devices are, they are not computers. Okay? BirdDog devices, NDI devices, they're not computers. They're nodes. They're NDI nodes. They're just network. They are devices on a network that have been assigned an IP, and they're doing their job at that location. That's what they're doing. They're not navigating the network. They're not learning who's who. They don't have an internal routing table. They're not pinging the network to find out, hey, sending out a lookup table or anything. They're not doing any of that. They've been assigned an IP address, and they're doing the one job that they're supposed to do, and that is send video down the line or decode. But people make these assumptions that they're like Windows computers or a Mac, or they're, even like Raspberry Pis, where they have these iOS interfaces that are doing all this network navigation, and they are not. They are nodes on a network, and a node, all that is a device doing a job at that location. So with that in mind, when you start making connections, right, you start saying, okay, I want that camera to go to this decoder. How is that information getting across the network if there's nothing actually steering the traffic? So we've got, let's say, an unmanaged switch and everything's set up in static. Well, when you power them on, the devices will send out a broadcast packet, and anybody that's listening will be able to see it. But if there's nothing that's actually keeping track of that routing information, that information is going to go away. And so, thus was born, I don't think in this sequence, but NewTek did everybody a massive favor, or NDI now, I guess is the proper way to think about it. NDI did everyone a massive favor and invented Discovery Server. Now, what is Discovery Server? Well, Discovery Server is the way that you can point your devices at something that is listening and then can provide routing information to those who want to decode that information. And so I always think, now, it took me a while to get to this point in life, but I think Discovery Server was meant to be a part of every NDI installation. If you were doing NDI on a network, it was kind of assumed, I think, that you would use a Discovery Server, mostly because it optimizes whatever network you've chosen to use, whether you're using static or DHCP. So, to optimize, to make things more efficient, and I genuinely believe this, by the way, to make things more efficient, you would run a Discovery Server. And Discovery Server would help direct traffic through the network. So, requirement number 2, the first is you need a managed switch. You need a layer 2 managed switch. The second thing is you need to be running a Discovery Server, which requires a Windows PC at base, okay? So a computer that is on all the time. This can be a VM, by the way, but it's a computer that's on all the time on your NDI network. And you'll notice that inside of all BirdDog devices, but all NDI devices, anyone's worth their salt at least, they have an option to add a Discovery Server. And so you would run Discovery Server, which just looks like a little MS-DOS prompt. Okay, add it to your Windows startup. When Windows boots up and the user logs in, Discovery Server turns on. And because you're running in a static environment, you would set your computer to have a static IP address. And then when you fire things up, you would turn on Discovery Server. It would operate at the IP address that that your computer static IP address is at. And then on all of your NDI devices, every single one of them on the network, you would type in the IP address of and hunt and peck if you have to. You would put in the IP address of the Discovery server and hit on and then apply. And then probably restart video just to give it a fresh start. Whenever you do network changes on a network node, that's just a general good practice is to probably restart them to make sure the change took, but also then to start fresh and new the way that the Discovery server is configured. And you should see, you watch Discovery server, and it's really cool now because they have a kind of a graphical interface that's happening on that DOS prompt. You would see when the node comes online, you would see that it's registered with Discovery server. Now, Discovery server then could gather that information, and then any decoders that appear on your network that are pointed at Discovery server would be able to see any sort of sources that are on the network. This is ideally, I think, the way to operate in static. But you're probably thinking, man, this doesn't seem a whole lot easier. It seemed more complicated to do this in static. And I would say, yes, you're right. It is. It does appear to be more complicated, mostly because you have to have more stuff set up to do that. So not only do you need to set all the static IP information in all of your network nodes, not only do you have to configure a Windows or a Linux machine, by the way, which is being sent over here in the chat. It does run on Linux as well, if you'd like. You have to have that machine on constantly, 24/7, or at least whenever you want your NDI network to work. It needs to be probably booted first, by the way. And then in the sequence, so if you're run and gun and you have to run static, you'd want that machine to turn on prior to your NDI network really powering on. So you need to have everything pointed at Discovery server. You need to have that Discovery server running constantly. You need to make sure that that service is up and running. And then you would need to then configure your entire infrastructure to operate that way. There are a lot of places. This is my warning about static. There are a lot of places to get it wrong. Okay? There are a lot of places to screw it up. And I've seen it over and over and over. I've seen it where people don't put in default gateways. And you think, well, I have a static network. I don't have a gateway. Yes, but you have to put that information in. When you go to static, that's one of the boxes you have to fill out. And so if you don't have a static gateway, or if you don't have a default gateway in a static configuration, here's a little pro tip. Set it to the IP address of the Windows machine that's running Discovery server. That will help. But there are multiple ways of messing it up. And that's the danger, is that although it may seem on the surface as this is the way I've always done it, this is the way that it makes sense to me in my brain, there are so many places for you to miss a digit, to put in the wrong information, to put in the same IP address, for example, for two devices, which would give you an IP conflict. There are so many places for this to go wrong. Now, you, of course, would never screw it up. But I'm talking about other people messing it up, and especially other people who didn't set it up and install it. Maybe they get in and they start thinking, man, this IP address isn't working for this camera. I'll just change it to the next digit up, not realizing that you have that set for a computer, which isn't outputting NDI, right? That's not its function. That's the Discovery server, or that's something else. There's so many places for this to go south. And so instead, you really need to know top down how it's configured and what functions it how it needs to power on, what sequence it needs to turn on, how it necessarily needs to be, all of the little fields and everything have to be double and triple checked just to make sure that this configuration works. And it can be daunting then trying to explain. So let's say you set this up for a customer, and then it's your job to explain how it's configured and how they can use it. And you might think, oh, it's so easy. Everything's just preset. You don't need to change anything. It's all well and good until something goes wrong or a device stops responding and they need to try and troubleshoot it. There's just so many places. This is my massive hesitation with static, is there's just so many places for this to go south. And we could use a system that doesn't leave too many openings for that to happen. At least we could mitigate how many problems that we're having. So static networks have their place. I'll round it out by saying it this way. This wasn't going to be a rah-rah speech for static networks, but I can say this. I have seen static networks successfully used in the NDI realm. I have seen poor static configurations, and I have seen better static configurations. If you're going to do static, I strongly recommend that you look at managed layer 2 switches or better, or more sophisticated, so layer 3, and you look at, you have to run Discovery Server, which requires a Windows machine or a Linux machine to run constantly, full-time, all the time. Now, I would love to test, in theory, running Discovery Server on something like a Raspberry Pi on a Linux, just because it's so lightweight that you might be able to fit that into a freight case and have that power up on a sequencer, and it would work probably pretty well. But if you have to do static and you have to configure every single unit, then be sure that you're using a managed switch and be sure that you're running a Discovery Server and everything on your network is pointed to that Discovery Server. I think you'll have the best results that way. And yes, then you don't have to give up your assigned IP addresses the way that you're comfortable configuring those networks. But if you're willing to go one step further, there may be a little easier and a little more sophisticated way of accomplishing the same goal with some redundancies built in so that when things do go wrong, they're not so difficult to troubleshoot. So there you go. It can be done. I promise you, static networks can be done. It's just a little more complicated if you must. Now, we'll do another session. We'll do part 2, and we'll talk about DHCP services and why I think that this is the path forward for the majority of NDI users. If you have a use case where static is just the only option, I would love to hear more about it. We'll jump over the chat after this segment and talk through some of that. Always willing to discuss, in what scenario that might be better received. I haven't found too many cases where it's absolutely mission critical, other than the IT departments are just not willing to have a dynamic license or a dynamic IP address. But beyond that, if you're the one setting up the network, I haven't found too many folks who just would not do a different configuration other than static, other than it's just their preference. So, all right. Join us next time. We're going to talk about those other network configurations and give you some insight as to other ways to design your NDI network, and that'll be next time.